Explore 800,000 galaxies. Now the James Webb Space Telescope has just opened a cosmic gateway, and you're invited in. For the first time, nearly 800,000 galaxies, some dating back 13.5 billion years, are freely available to explore in a massive interactive map. This isn't just a scientific tool, it's a time machine, revealing the infant universe in extraordinary detail. Released by the Cosmos Webb project at Caltech, this is the largest deep space map ever shared with the public. In this video, we'll break down how this map was made, what makes it so revolutionary, and why this is a historic turning point in astronomy for everyone. Cosmos Webb's Deep Dive. Behind this breathtaking cosmic map lies Cosmos Webb, the largest survey ever conducted with the James Webb Space Telescope, JWST. Led by scientists at Caltech, this initiative set out to map a small, focused area of the sky with unprecedented depth. The result: a treasure trove of galactic data now made available to the public in a beautifully designed browser-based tool. The map covers 0.54 square degrees of the sky, which might sound small until you realize that roughly the size of 3 full moons side by side. In that tiny sliver of sky, JWST found nearly 800,000 galaxies, not stars. Galaxies, each one potentially home to billions of stars, planets, and perhaps even life. What's more, some of these galaxies are 13.5 billion years old, meaning they formed just 300 million years after the Big Bang. That as close to the beginning of the universe as we've ever been able to see. To build this map, JWST used 2 of its powerful instruments, the near-infrared camera, NIRCam, and the mid-infrared instrument. NIRCam scanned the entire field, giving us a crisp, high-resolution view of stars and galaxies. MIRI focused on a smaller portion, 0.2 square degrees, but in longer wavelengths, revealing hidden features like star-forming dust clouds and ancient red-shifted light invisible to human eyes. This mix of data created a layered, textured view of space, blending broad near-infrared coverage with focused mid-infrared imaging. The total size of this dataset? A whopping 1.5 terabytes. It's rich, complex, and ready to be mined for discoveries. Each tile of the map is digitally stitched from thousands of exposures taken over months. The instruments catalogued the brightness, distance, shape, and structure of each galaxy, offering researchers a detailed database of the universe's early architecture. And unlike earlier deep space images, this isn't locked away in academic vaults. This map has been made public and interactive. Anyone can open their browser and start exploring the cosmic web. For the first time, the formation of galaxies, stars, and structures from the dawn of time is no longer just a research subject. It's something you can experience firsthand. Why this changes? Everything. What makes this release truly groundbreaking isn't just the number of galaxies, it's what we can learn from them. This data offers a direct window into 98% of the universe's history, which gives scientists the clearest picture yet of how galaxies evolved, merged, and matured over cosmic time. It's like flipping through a galactic family album, from baby pictures to adulthood. Before now, our understanding of the early universe relied heavily on small surveys or theoretical models. The Hubble Space Telescope gave us tantalizing glimpses of distant galaxies, but its limitations in the infrared spectrum meant we were mostly seeing younger, brighter galaxies, not the truly ancient ones. JWST's powerful infrared capabilities changed that. The Cosmos Webb survey captures faint early galaxies we've never seen before, of which are pushing the limits of what we believed was even possible at those epochs. This isn't just a tool for studying galaxies. The Cosmos Map helps scientists probe dark matter, the mysterious substance that makes up most of the mass in the universe. By examining how galaxies are distributed and how their light is bent by gravity, a phenomenon known as gravitational lensing, astronomers can infer where dark matter is hiding. This helps build better models of the universe's structure and evolution. Another breakthrough is in understanding star formation. The map includes dusty regions where new stars are being born, something previous telescopes struggled to capture. Mid-infrared imaging helps cut through that dust, allowing us to study the birthplaces of stars at different stages of the universe's life. And then there's the question of supermassive black holes. These titans sit at the centers of most large galaxies, including our own Milky Way. With JWST's resolution, researchers can better detect the energy signatures that indicate black hole activity in distant galaxies, helping us understand when and how these behemoths formed. What is astonishing is that all of this came from a single patch of sky just over half a square degree. Imagine what we'll uncover as JWST continues to scan the heavens. In short, this dataset isn't just an astronomical archive. It's a living tool that will drive new theories, discoveries, and maybe even new questions. It reshapes the way we study the cosmos, and thanks to open access, it opens the door for anyone to contribute to our collective understanding of the universe. The map in your hands. Now here's the part that truly breaks the mold. You can explore this universe yourself right now from your browser. The Cosmos Webb team didn't just publish research papers and data logs, they built an interactive map that invites everyone in. Just go to the Cosmos Web viewer and you'll see a zoomable, clickable map of the entire survey field. What looks like a colorful mosaic is a rich astronomical interface. Each segment of the map corresponds to a tile of the sky observed by JWST. You can zoom in, scan across, and toggle different layers in the top right corner. There are multiple view modes: NIRCam RGB, individual filters, and tile breakdowns. Want to see only mid-infrared data? Click a button. Curious about which camera captured a certain region? It's color-coded. Each galaxy, star, or bright object can be clicked on to reveal catalog IDs, redshift data, and even raw images in FITS format. Don't worry if you've never worked with FITS files. NASA has provided a list of FITS viewers that are free and easy to use. There's also a simplified view for educational purposes that overlays objects of interest and explains what you're seeing. If you're more hands-on, the data is also downloadable. You can choose to download individual map tiles or the entire 1.5 TB dataset. And if that sounds overwhelming, the site includes clear instructions and tools to help you get started, even if you're a beginner. This is more than just a digital map. It's a platform for discovery. Educators can use it in classrooms. Students can use it in research projects. Citizen scientists can dig into the data and potentially spot anomalies or rare objects that haven't been identified yet. It also empowers creative exploration. You can visualize star formation regions, trace galactic filaments, or simulate cosmic growth over time. The possibilities aren't limited by budget or lab access anymore. They're defined by your curiosity. By making this data public and easy to explore, Cosmos Webb has turned a cutting-edge scientific survey into a shared experience. You're not just looking at space, you're diving into the oldest chapters of the universe. You're not waiting for discoveries, you're part of them. So whether you're a data scientist, an amateur astronomer, or just someone fascinated by the night sky, this map is your invitation to engage with the cosmos like never before. The universe just became more accessible than ever. Thanks to JWST and the Cosmos Webb project, we can now explore 800,000 galaxies, some formed just after the Big Bang, right from our screens. This map isn't just a scientific achievement, it's an invitation for everyone to dive into the cosmos. Whether you're a researcher, student, or simply curious, you now have a front-row seat to 13.5 billion years of cosmic history. So go explore, ask questions, and maybe even make discoveries of your own. The stars aren't far away, they're just one click closer.